So the next thing are these two resistor networks. These are SIP9s. They need to be bussed, and that's important. We'll talk about that. These are the pull-up resistors for the dip switches. And I've got a fair amount here. They're somewhat sorted. I'm going to look for some matched. Actually, those shouldn't have gone in there. I don't know if they're bust. Bust means there's one common pin, and then all the other pins are a value resistor tied back to that common pin. Non-bust mean they're individual resistors between the two pins. So in this case, they need to be bust, because you're going to have that one pin tied to the 5-volt rail, and then the resistors inside are going to get tied to each one of the pins on the dip socket. So this is 1, 2, 3, 4, 5, 6, 7, 8. Those are 10 pin. He spec'd this for 9 pin bust. Those are 10s. See if I can find a matched pair of 9s in here. This is a mix of new old stock and pools. When I pull, I always go through them with an ohm meter and make sure I haven't damaged them during the process of pulling them. Hopefully I've got some 9 pin mixed in here. I seem to have 10 and less than 9. To look at the footprint, he may have put a 10 pin footprint on the board, just because 10 pin is more common. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He's actually got a 10 pin footprint on the board, which just means one of the resistors is wasted. So I should be able to put one, go there. I'd like a matched one for over here. So I've got 2 resistor networks. I'm going to put the rest of these back in the box and get the box out of the way. I'm going to hit these both with the ohm meter and look at every resistor, just to make sure that they are actually good. Meter. It'll come up here in volts. I need to let it initialize. This is my Rigol 3058E. It's a really nice little meter. Really happy with it. So I don't know how well these will show up. See if I can get them on a white background. Got 2 of them here. They're 10 pin. There's a little marking to this side that identifies pin 1. Oh, the pointer's magnetized. Pin 1, that'll be the common pin. And then each of the other pins across the device will be should be a 1K ohm resistor, assuming when I sorted these, I sorted them well. These do look like they're new stock or new old stock, either way. 996 ohms, 996, 996. Yeah, I mean, we're looking for 1K, so 996 ohms is plenty, close enough. And of course, I don't think this end resistor out here is used, but I'll check it anyhow. This is also proving that the pin with the marking that I've got the red lead on is the common pin. I've a couple times using pulled resistor networks ran into issues where one of the resistors inside had gone bad and was open, and I didn't have pull up there, and that can be rather ugly to troubleshoot should it cause problems. Yeah, all the resistors in these look fine. On the board, so you can see this here, pin 1 is marked, that's where the common pin goes, and pin 1 is marked here. So really, that'll drop in that orientation, this drops in this orientation. There's always a bit of painter's tape to kind of hold these in place. It's always kind of hard getting them exactly square. I always solder one pin, come back, and square them up, because it's kind of hard to do otherwise. We'll go through and do this. So one of them is sitting here, and I'm just going to solder up one pin. And the other one is sitting here, and I can see he's extremely crooked. I like them to be nice and straight on the board. No, it's a little too far, although that was close enough I can just bend him a bit. Looks pretty square there on the back. Once you get all the pins soldered, it's almost impossible to straighten these up. Still see that I'm not happy with that. That's better. Again, it's a visual thing, it's not critical, but I know because I did the assembly. So I'm on that square pin, the common pin. Just walk through here, soldered this up, and there's the original pin I tacked that I'm also going to hit with some solder. I can see an IC socket over here that I missed soldering earlier. He is in flush. I'm actually surprised I missed that socket. I did actually inspect the solder joints, so even in my inspection, make sure he's flush. He is. And I guess while we're here, we'll hit up these pins. The joint looks a little cold. The original corner pin that I used to tack him in place. Those solder joints I'm not happy with. That's better. So we've got the two resistor arrays in place. We've actually soldered up the socket we missed. Back to the assembly instructions if I can get things out of the way. And it's these two resistor packs. The blue pin, bend done. He calls for the edge connectors next. I'll do that in this segment. Two these guys out. I'm be pretty excited to get this guy installed in the system and see if it works. The two little hooks go under the board. Then the single row of pins into the solder pads, just to kind of hold it in place. Oh, getting too much stuff on the bench. What is cable for the wow, that's interesting. How did that get wrapped around like that? The lead for the solder. handle here suddenly got wrapped around the solder station in an odd way. A little bit of pressure to the board. I'm going to get the two ends. Give it a check for square. Oh, that's a ground. It's going to take a bit of heat. It's not a they look square to me. They are flush to the board. I think this one might not be. It is. And really now it's just walk through these and solder them up. I'm going to come back now to that first pin that we just used to tack it. It's one of the +8 pins. These are signal pins. Yeah, watching me solder, I'm sure it's highly exciting. I know I've had a few comments that people kind of like watching me putter around with this stuff. So I'm sure when I get to editing this will be a multi-part video, just because posting a 2 or 3 hour build as a single video seems torturous. I need to clean the tip. One of the attention to detail things I really like is on this board, there's a set of holes here that come off the edge connector that I could put a post into to say wire wrap onto if I was going to prototype. I needed to bring some additional signals onto the card. So actually didn't want to touch that one first, but I did. So it's just a little attention to detail that with that prototype area could actually be useful, rather than trying to solder directly onto these pins here. So I think that's kind of a nice attention to detail. I think those holes are actually meant for a different style of connector, actually, now that I think about it. I think I've got some that have 2 pins that come off the connector, so you'd be soldering both ends rather than relying on the little nylon hooks to keep them from folding. But still, those holes could be really useful in this configuration for prototyping. These two down here are going to take some heat. They are ground, and I want a good connection, and this is a little bit of a small tip. It'll just take a little more time. The JBC is more than up to the task. I'm going to reflow this one just because it's the one I tacked in place originally. Well, that looks pretty awesome. They're nice and straight to each other. They feel solidly attached, at least as solid as they can be, relying on the fact that it's got these little clips underneath to keep them from flexing. We're definitely making progress here. So I'm going to take a little break. I've been going at this pretty steady. Highly recommend taking breaks. Come back fresh, and we'll continue to build. So I'm going to move on to dip switches next. Looking at the leads on these, they're pulls, which means I salvaged them from some piece of gear. So before I commit them to this board, I actually want to test them. it is possible to damage these. I believe in this case all the switches in this one are on. I guess we'll find out. Well, apparently they're off when it's to the dot. Actually, it would help if I was on adjacent pins. Again, it would help if I was on the correct pins. A little tight here. Those all seem to be open, and I'm assuming they should be. Looking at it, the lead lengths are all the same, so I'm going to assume now that in the opposite direction, these are going to be on. Okay, that seems to be okay. These should all be open. It looks like they are. I'm not hearing continuity across any of those. Let's turn them all on. And just come across to this side. Pins on this side. Again, better to test than have to remove. So just a quick test, these all look okay. So on is in this direction. So this is a bank select, and this is a status port. Let's see what the text says about dip switches. I'm reading something about kind of ignore the numbers, you know, the 1 through 8 printed on the switch, as it may not agree with what's in the little manual here. See if I can find that soldering tutorial. Appendices. So we determined, I believe, with the switch to the dot is off. Yep. So I'm going to install him oriented. Pins are a little, how you doing? In this direction, so I click down towards the bank that I want enabled. So it looks like for PAM 8, it would be that configuration where the 8 through 56K selectors would be on. 2, 3, 4, 5, 6, 7, 8. It's interesting, the silk screen actually is this orientation here, but that's fine. He's going to go in that way. Get him roughly held in place. Numbering on the switch may not match numbering on the silk screen. Always use the number on the silk screen. And there is the org 0 extended. It doesn't really give which pin here is 1 or 0 or 2 or 3. I mean, there's no notch, there's no indication of what orientation. Let's take a look at the board photos wherever they are, just to see if there's more of a hint in there. I know there's a board photo here someplace. and I just put them in. This will be my normal solder the opposite corners, make sure they're flush, and solder the rest of the pins. Sure it's flush. And that one is. And that one is. Now we can just walk through the leads and solder these up. See, if you're going to use pooled components as part of what I have here, test them ahead of time. You know, my test wasn't super exhaustive, but I saw each switch open and closed. I'm going to assume there's no shorts between the switches. Anything's possible. Gets his dip switches. So let's see, these dip switches are in. Let me get the other glasses. These sockets are in. 16 pin. 20 pin, 32 pin. I'm not going to put in the battery. I need to see if I have that RAM in my stock. DS1210. I might actually have a DS1210 someplace. Oh, Install one. There's probably a couple of parts here I'm going to have to order. I do need to install some headers. Install 4 1x2. Get a header strip. Nice one here with gold pins. So let's see, it said there are 4, I believe 2 pin. Install 4 1x2 AP1 2, 4, and 6. You don't want to snap, huh? And there are 3 1x3s. Hopefully I'm somewhat in frame here. And these should be fairly obvious where they go. Well, I say that. Those are test points. So there's JP2, side select, charge. We'll start with those. We'll work on from there. I'll hold them in place here. Don't know how square they are. But again, I'm just going to tack one pin, straighten them up, finish soldering them. It's right here. Right here. And I can see just by looking that they're not square or in straight. Pretty sure I'm off camera. Apologies. Yep, you saw me burn myself. Not exactly straight. I always find these a pain. This one is certainly not straight. This one's not perfectly straight either. Looks pretty good. Another 3-pin here, a 2-pin here, and a 3-pin here. So 3-3-pin and 1, 2, 1, 2, 3. Where's the 4th 2-pin go? JP2, charge, board disable down here. Again, I'll solder 1 pin on all of those. And then kind of fudge with them until they're straight and then flush. 1, 2. Got those 2. There's one right here. And there was a 4th one. Which direction down here? Oh, and I missed a 3-pin someplace. It just fell out. Now we'll come back to it. Looks pretty good. Oh crud, I soldered up 2 pins for some reason on that one. Certainly didn't want to do that. Let's see if I can get one side to unsolder, so I can hopefully straighten it out. though I made the right number of solder connections for 4, I actually soldered one twice. That actually looks pretty straight right there, so we'll go ahead and solder him up. We've then got this guy. How straight is he? Not perfect. Fell down flush. Still not square. That looks pretty good. I've got a 3-pin in here next to the dip switch. Not as square as I'd like. That's good. So while I'm using my finger on the other side of the board to straighten it up, I'm obviously only putting pressure on the pin that I'm not heating with the soldering pencil, otherwise you'd burn the crud out of yourself. So we have put in the 3-pin, all 4 of the 2-pin. I'm not considering using the battery backup for now, although maybe it'll come down to it, I don't know. You obviously need a voltage regulator and some supervisor chips that I don't have. TL7757, which I'm assuming there's a transistor looking footprint on here, I believe. Or maybe I'm crazy. Yeah, right there's the TL7757. And a DS1210. I might have a DS1210. I question the need for that reset at this point for the testing I want to do. And 3 LEDs. A voltage regulator and a heat sink. Well, when I come back, we'll get those components installed.